Yeah. I mean, it's okay. So for those on, we've got the recording and once again, AJ Coleman. Thank you so much. I'll pass it over.
Well, yeah, the microphone's also short. It's not just you. Good afternoon, everyone. I'm AJ Coleman. Unlike Dr. Cahill, I was only an aspiring scientist who traded it in for engineering. I've been actually working at NASA for about 14 years now doing satellite operations. And I'm just really excited and happy to be here and have the opportunity to lead this panel. Now, I don't see them. Can they see me?
We can see you.
Okay, all right, great. Then I'll start brief introductions. It's my my hope to do as little talking as possible and let you guys really shine. We have Brett Lindenfeld, VP of Programs, Motiv Space. We have Dr. Not sure if it's Angel or Angel Abbud-Madrid, a director of the Center of Space Resources at Colorado School of Mines. And we also have Lieutenant Colonel Rock McMillan, who is the director of SPACEWERX. Let's start off with Mr. Lindenfeld, and please take a few minutes and introduce yourself.
Well, thank you very much. Yeah, my name is Brett Lindenfeld. I'm the Vice President of Programs for Motiv Space Systems. We're a small engineering and development firm out in Pasadena, California. I don't know if this was the time. We put a small introductory package together. I don't know if this was the time that you wanted me to go through that or not.
Go ahead. Yes. Take your 5 to 10 minutes.
Sure. Is that being shown to the audience or not? Because I can't see the screens that they're viewing.
No, they're looking at us, Brett.
Okay.
It's coming now.
Okay.
There we go.
Terrific. Great. I could do it all with hand gestures in mine, but I thought slides would be better. Anyway, if you can advance to the next slide, I'll go through these really quick. And I apologize for the slide effects. I didn't know those were in there. So yes, we're a small robotics and motion control company. We were founded about a little over 7 years ago in 2014. Primarily focused on robotics and motion control mechanisms and motion control electronics. We have a multidisciplinary team here from system engineering and avionics and embedded software and mechanisms, and have been working programs for NASA, civil space, commercial space, much more recently in DoD. We are located, as I mentioned, in Pasadena, California. We have a 10,000 square foot facility that we're currently occupying, and we're just moving into at the end of this year into another 6,000 square foot facility just down the street. So next slide. Yeah, sorry again. You can keep, yeah, hopefully they all come in. These are some examples of our flight programs over the last 7 years. Most notably, we delivered in 2019 the robotic arm for the Mars 2020 Perseverance rover for JPL. That's pictured there. You can see a small inset of one of the first shots we got of it after landing on Mars. That was fully developed here at Motiv, engineered and built and integrated and then delivered to JPL. Additionally, on that mission, we did the camera lens assemblies for the mass cam primary science optics on the rover. You can see some of the actual images that were taken with that camera. Those images also that are shown up in the upper center also included filter wheel mechanisms that we designed and built for that mission. Then moving down, a number of different electronics programs, drive electronics, motion control, drive electronics for various robotics applications. And most recently, we are delivering a new commercial space robotics platform for the OSAM-2 mission that NASA is funding under subcontract with Redwire, what was formerly Made in Space. Next slide. one of the things that we've really tried to do is kind of fuse a number of different capabilities towards our flight programs. We have a number of different flight motion control electronics programs there. We're showing a number of different products, and then infuse those into these flight applications I showed you on the prior page. We've also endeavored in the last 7 years to develop a ground robotics capability, leveraging technologies from Caltech and licensing those. And we've developed some mobility robotics that you see on the right-hand side. We call that vehicle RoboMantis, and it's a highly modular robotic system. And then a few years ago, we had the idea to try to lower the cost of space manipulation capability by at least an order of magnitude. And so we sort of fused the robotics capabilities and hardware that we had successfully delivered for the JPL Mars missions and combined that with some of our ground robotics. And we developed a product for commercial space that we call X-Link, which is shown in that inset. And that's the first X-Link robotic arm is what we were delivering for Redwire under NASA's OSAM-2 program that I mentioned earlier. Next slide. And along those lines, next slide, sorry. We've utilized the SBIR program quite successfully. And in 2017, we developed a cryogenically capable motor controller for future robotics missions. That then was converted to an SBIR Phase 3 that in partnership with JPL, we're working a program called Cold Arm, which will fly an Eclipse mission to do some cold temperature demonstration digging with some technologies that JPL is developing using BMG, bulk metallic glass technologies for very cold operations, and coupling that with our SBIR innovated cold temperature electronics. And this is scheduled for launch in the 2024 timeframe. Next slide. And this just shows, again, some of the OSAM technologies that we folded in for OSAM-2, the picture on the right-hand side. We've also been supporting OSAM-1 and other on-orbit manufacturing activities that are going on within NASA and the commercial community. Next slide. And yeah, sorry, I got ahead of myself. This shows some of the Restore-L, what was Restore-L, and now some of the OSAM-1 satellite servicing activities. We developed all the engineering model electronics that are driving that robot in Goddard's lab today for the OSAM-1 robotics program that's driving their EDU. Next slide. And then finally, we're working various studies with NASA right now, leveraging a lot of the work that we had done for the 2020 Curiosity rover and supporting NASA and JPL on the MSR program. And so we're looking forward to the next phase of Mars exploration, continuing with what we've done with them in the past. So I was hoping to try to keep that to 5 minutes. Hopefully that was close. Sorry if it wasn't.
Oh, no, you did great. And I really would have enjoyed seeing the hand waving version of that presentation.
Yeah.
Dr. Abbud-Madrid, please let us know about yourself.
Thank you, HA. Thank you. I'm the director of the Center for Space Resources at the Colorado School of Mines, and thank you for the opportunity to be part of this fall meeting of the LSIC, a conference in which I'm pretty sure that all participants in person or online are fully understand and are well aware that we are going to the moon. This is real. This is happening. And it's not just touching the surface and coming back, but we're going to the moon to stay. Now, the question is, how is that, who are the we that are going to the moon, and how is that we going to make and achieve a sustained lunar presence and operations? As for the we, is no longer two countries racing for the moon like in the 1960s. We have a variety of countries now that have very definite plans specific dates and even places where to land and where to conduct extended operations on the lunar surface. We have companies now that are providing the transport, the landers, the rovers, and dozens of companies, just like Motiv Space Systems, that are providing payloads and also are trying to insert themselves on providing all the infrastructure that we're going to need on the lunar surface. And it's also academia doing what we do best, which is provide new knowledge and technology development and educating those professionals that are going to be involved in this major undertaking that humanity is attempting to do on the moon. Now, on the how is that we are going to accomplish these objectives, I think it is pretty clear by now that space agencies and the traditional aerospace companies clearly realize that it's no longer about just rockets and satellites and probes, that now it's going to take a whole new set of players, new disciplines, new areas of expertise to accomplish all the things that we want to do on the lunar surface. So it's not just about providing remote sensing to let us know what's available on the lunar surface, but it's getting down to the surface and drilling for prospecting and developing excavators to collect the material and also extracting the oxygen and the water and the minerals and the metals and processing them and separating them and storing them and all the infrastructure that will come along, power, telecommunications, and also transport within the lunar surface. And all of this requires innovation and creativity and from all sorts of new players and new disciplines in this field. And so as described by the associate administrator this morning, NASA has been addressing all of these topics through many mechanisms. And some of them we're going to be discussing in this panel, all the way from very futuristic TRL-0 ideas from NIAC, all the way up to TRL-9 and designing space flight hardware, again, like the one that Motiv showed a few minutes ago. And also he's doing this through very effective through competitions and challenges that involve the general public, the academia, companies large and small, to provide innovative concepts that are needed. And so realizing the many benefits that challenges can bring to accelerate new concepts, the Colorado School of Mines, as one of the several activities that we have to connect academia with companies and with space agencies, came up with an idea to have a competition and a challenge emanating from the collaboration of universities and companies, so that we could address some of these gaps that we see on technologies that need to be developed on the lunar surface. And so it is that between the School of Mines and Lockheed Martin, we came up with a challenge called Over the Dusty Moon Challenge, and in which we're trying to come up with ideas that not only will be good for Lockheed Martin that wants to do this type of operations on the moon, but by everybody that is going to have to access the lunar surface. And we decided to have our first theme, the first topic for this year, on an area that may seem simple or very mundane, which is just transporting material from point A to point B. How to collect from the place where the regolith is excavated to the place where it's going to be utilized for extracting resources, for construction, for manufacturing. Do this in a very efficient way by lowering power and mass and volume requirements, and doing this to minimizing the effects of the lunar dust, which is quite detrimental. So this is an ongoing challenge that started in September and will take place at School of Mines in late May, and that will be involving all universities around the world. This is an international competition. And also it will involve all the major players. I mean, NASA will be involved as judges, and other companies will be funding some individual teams to make this possible. Because what we want is the best of the best ideas that we need, and not just for the topic of this competition, but for all of the things that we're going to be doing in the lunar surface, so that we can answer the how is that we can make this a sustainable operation, and also the we, and how can we make the we as inclusive, as diverse in terms of professional experience, of expertise involving the government, the commercial sector, academia, and doing it internationally, so that we can achieve all of the big ambitions that we have on operating on the lunar surface.
Thank you, Doctor. That was fantastic, teaching us how to live off the land, even if the land isn't on Earth. And finally, Lieutenant Colonel Rock McMillan.
Yes, thank you. So first off, really would like to thank you for allowing me to come and participate in today's panel. My name is Rock McMillan. I am the director of an organization called SPACEWERX. As director of SPACEWERX, I'm also dual-hatted as a deputy director for AFWERX, a Department of the Air Force innovation organization that focuses on driving investment into early stage small businesses and startups. So as the deputy director for AFWERX, I do focus on the space portfolio. And so we just started SPACEWERX back in August of this year. And it's not, this is an ecosystem that's not entirely brand new to us. We've been working in this mission innovation ecosystem for at least the last 3 years. And so as the director of SPACEWERX, our main tool for getting after investing in R&D is the Small Business Innovative Research Portfolio. So Brett from Motiv talked a little bit during his introduction about some of the SBIR work that they have done with NASA. And so it's through the SBIR portfolio where we, use that to begin to lower the barriers of entry for small businesses and startups to come to the table with some of their best ideas and contributions that they have to offer to not only the Space Force, but just the entire space architecture altogether. And so from a Space Force perspective, when we look at where R&D investment is currently being driven, 80% of that investment is being driven through commercial means. 50 years ago, it was a bit of a different story. Much of that investment was being driven through defense channels. And that sort of put us into a situation where, we were very prescriptive about the needs that we had within defense. And so every time we set out for a request for proposal, we were driving a lot of R&D within the ecosystem based on the requirements and needs we established. Well, what we've noticed over the last 5 years, especially again, is there's been a lot of great innovative activity going on within the space architecture outside of DoD. And so because of that, it's imperative for us to take advantage of the opportunities that's going on, within academia and commercial industry. So we started with the SBIR portfolio. Started to pivot the SBIR portfolio to be a strategic investment tool that we use to lower the barriers of entry again for startups and small businesses to come and bring their brightest ideas to us. In fiscal years 2019 and 2020, over 1,400 companies were placed on SBIR contracts. Of those companies, over 75% of those companies were brand new in doing business with the government. And with that, those companies have brought to bear some great products, right? And so now, rather than the government, again, driving our requirements through this SBIR open topic, we allow companies to bring their brightest ideas to the table and take those bright ideas and introduce those bright ideas to our technical SMEs and operational users, and help those companies understand their value proposition to the government. The other great thing that we've learned from the SBIR open topic has been the amount of private investment that has been occurring within this ecosystem. So not only are we using SBIRs, as an investment vehicle for the government, but private investors are paying attention to where we're driving some of our investment. From our SBIR dollars, we're seeing matches of $5 to every one SBIR dollar that we invest. So for us, it's all about, doing what we can to help build that industrial base, that space industrial base, to onboard the brightest minds, the best companies, to, again, deliver the best technology on the space layer. So it's a very exciting time, to be on board as the director of SpaceWorks. There's a couple of initiatives that we have coming down the pipeline really soon that I think this audience would be very interested in. Tomorrow afternoon, we're going to make an announcement for our new Space Prime initiative, where we're going to focus on a very specific mission area and drive investment, offer government resources to take some nascent technology area that, if primed by government interest and resources, can potentially fully commercialize an entire mission area that we're interested in. So shortly after the Space Prime announcement, on 19 November, we're going to have an STTR open topic call. That open topic call will focus on engaging academia and startups to come and partner with us in competing for contract awards up to $250K to help us tackle some of our toughest issues. Right now, we're willing to award up to, if not more than, 50 STTR Phase 1 contracts. Again, this is our effort to take our toughest problems, push them out into that academic community, and energize academia to come and partner with us as we try and not only build the industrial base, but again, take advantage of some of the innovative work that academia is doing. So shortly after the STTR open topic call in the spring of next year, we expect to do another SBIR open topic call as well. So SpaceWorks, very exciting time. My senior leadership from General Raymond down to Lieutenant General Gutlein here at Space Systems Command in Los Angeles, California. They're placing a premium on truly innovating and bringing on new capabilities that will not only help us build the space industrial base, but also capabilities that we can deliver to our warfighters. Thank you.
Thank you, Colonel. Now, Colonel, you and Mr. Lindenfeld both really talked about the SBIR programs. Could either of you, I guess, Mr. Lindenfeld, really discuss its benefits to you as a small company and how the SBIR program has reduced barriers for you?
Yeah, so for us, the program it has been very effective in terms of providing the seed funding that we need to take the ideas that we have and turn them into reality. The SBIR program works best when you can couple the topic areas of interest from the government. We primarily have been focused on the NASA side, but this is also the case with on the defense side as well, and on the Space Force and Air Force side as well, that are strategically aligned with the vision of the company. And that's what we really tried to do, to not see the SBIR program as an end of itself, but as a means to further the technologies that we are already in our pipeline and that are part of our strategic vision. And utilizing essentially this government R&D effect like that, it has this tremendous leveraging capability. So as an example, what I was showing before, we had an SBIR in 2017, a phase one, $100,000 or so, to develop this controller idea that we had of how we could take a controller to cryogenic temperatures. And we did a phase one, did some early testing. We wouldn't have been able to afford that on our own. We wouldn't have been able, that would have been an R&D burden that we couldn't have taken on, but it was very much aligned with where we wanted to see that technology go. And then obviously that led to a phase two, and we had a very successful phase two. And the interesting part about it, at the end of that phase two, the research was all very successful, and we had a cryogenic controller, but we also had a controller that was developed that had commercial space use in traditional temperatures, not just a cryogenic, and we were able to bring that product to market because not right now commercial industry is not really screaming for cryogenically cabled motion controllers, but they are screaming for lower cost space-based motion control or brushless DC motion control devices. And without the SBIR, we wouldn't have been able to take that product, get that product ready for market. And so it had two branches. It had the research itself that could foster what later became this phase 3, where we are applying this technology for this cold arm mission, for this lunar demonstration mission, for being able to demonstrate robotics technologies that can operate with very low power across a lunar night, for example. But we also have this parallel track that the SBIR led to of a viable commercial product that we are now selling, and we've sold to multiple users, both government users and commercial users. And all of that wouldn't have been able to start without that SBIR seed funding.
Excellent, thank you. Colonel, it looks like we have a question that came in for you. How would you alter STMD funding structures to accelerate innovation for the lunar surface specifically?
Right, good question. So, you know, there's a couple of things that we've already done within SBIRs to help begin to get after some of our cislunar activities. First off, it just starts with the open topics that we push out that we want to explore and pursue. There's work within our AFRL Space Vehicles Directorate, where a team is doing some research on lunar innovation and technologies. That team does leverage the SBIR portfolio to not only drive some of their prescriptive requirements through the SBIRs, but also as a market research tool to understand what's out there in the realm of the possible. And so once we lower the barriers of entry, and we do bring on promising companies, and they transition from a phase 1 to a phase 2. One of the interesting things that we've done funding wise to help address that transition piece, address scale of being able to scale prototypes that we find out of the SBIR phase 2 is something that we call the strategic financing program. If it's a dual use commercial technology, the strategic financing program allows us within SpaceWorks to take some of our SBIR investment, couple it with program office investment, so we can, if we have a program executive officer, an acquisitions expert that is willing to bring in the funding, I'm able to match that funding from that program office executive one-on-one with SBIR dollars. So, I double his funding. And then, we also allow for private investment to be able to contribute as part of that strategic financing contract. The SBA has given us a waiver to allow us to contribute, up to $15 million in program office funds, which allows me again to match that, one-on-one with another 15 million in SBIR funding. And we couple that with private investment. And so what we've seen with that program is, again, us beginning to address that transition value of depth, allow for scalability of prototypes, gives us flexibility in funding efforts and being able to leverage private investment to, again, scale. And then also, it allows for us to execute projects over a 4-year period of performance, which for the government is a critical time for us to inform long-term investment, in our portfolio through our POM.
Thanks. Great answer. Dr. Abbud-Madrid, let's throw you one, and the rest of you guys, by all means, please jump in. Do you have any advice on how we can foster engagement and development for different types of universities so that they can be competitive in government funding opportunities and or the commercial market?
Sure. I mean, I mentioned just one example of how we're trying to promote that by competitions and challenges that can address a certain topic. And that's, I think that's a great way for universities to get involved in this type of things. But the other thing that we've been doing, and related to what was discussed on how NASA funds companies through SBIR, one thing that we have been doing lately is to not just participate with individual companies on projects with SBIRs. I mean, we do that all the time, but we want to go a step further and try to see how we can identify how these companies that may be working on individual projects can now fit in what we call the space resources value chain. How can they now start working together to achieve what we want to have in space? Let me give you one example. Just a couple of weeks ago, we did one of those events in which we brought together 4 companies, all of them receiving SBIR funding, that are working on space debris. But one company, Astroscale, is trying to capture that space debris. The other one, NanoRax, is trying to capture that in a module and prepare it so that the third company, Lunar Industries, can process that material and extract metal from that, so that a fourth company, Newman Space, can use it as a propellant. So by doing that, what we're trying to do is to see how this can capture the attention, not just from NASA and other space agencies, but also from investors and other companies that can see how all of these companies can now work together to achieve something that we want to do. And the same thing can happen on anything that we do on the lunar surface for construction or manufacturing. Start bringing together those companies that are maybe working in different fields, but now you can see how they can all come together to achieve something and together. And universities can be playing with all of them in all of these steps of the value chain.
Thank you. Brett or Colonel, would you like a shot at that one?
Yes. The first opportunity for us, for universities to take advantage of some of the opportunities is our STTR open topic call that's coming out on the 19th of November. That open topic call does give you the opportunity to compete for some of our STTR phase 1 awards. So we'll release our interest areas, and we highly encourage universities to apply. Of course, that application process is going to involve a partnership with a research institution or a small business or startup in order to apply. But please be on the lookout for that open topic call. And so to learn more about that open topic call, we're going to host a number of Ask Me Anything sessions between next week and through the end of the open topic call, which is going to close out in late January or February. So please join us on our Ask Me Anything sessions, which we project is going to happen about once a week, every Wednesday. Up through January, and learn more about STTRs. It gives you the opportunity to ask questions, both questions on how you can apply for an STTR, and then also questions about the technology tracks that we're pursuing through the STTR. So that's the near term, probably best way for you to partner with us and take advantage of some of the opportunities that we're offering.
Thank you. Brett, do you want a shot at that one?
Yeah, from our vantage point as a small business, where we've gotten involved in universities is obviously in areas where there's real what's the right word? Fundamental research going on that we think we can help them turn into a viable practical application, a practical engineered application. And primarily that we find that on the instrument side where we can help. And we've had some interactions with universities in the past where they typically will have, for instance, a concept for a novel, maybe micro or scaled down instrument of some kind, but they really don't have the experience of how to turn that into flight hardware that's going to be viable on Eclipse mission, as an example. And so we, with the flight hardware expertise we have and what we've done, we can partner with those universities and sort of help them bridge from the lab bench or, you know, to a viable working model that we can then fly as a payload to, you know, to orbit or to the surface of the moon. And we've found with various universities that that's a very, it's very helpful for them, because obviously they are experts at the instrument and the core technology that they have, but their students and even their PhDs and so forth that are the true experts of what the science that they want to do, they don't have a lot of fundamental experience with the development process of flight hardware, and we can bring to the table that element of it. And then through that partnership, I think we can really put some innovative tools on, you know, on the surface of the moon, as an example, where it might feel a little far away for them when they've got, you know, a prototype working well on their lab bench. So we do use the SBIR program and also other technology development programs that come out to partner with universities to help them, you know, bridge that development. And we very much enjoy that partnership, because we're not scientists by trade. We're mostly engineers and technicians and hardware builders and so forth. And so the scientific community really comes out of those universities.
I think that Brett has a great point here. And just speaking from what we're doing at School of Mines, but also colleagues that I have in other universities, we're doing exactly that. We're developing, for example, in our case, the technology to have a prototype of how you can conduct or measure geotechnical properties on the surface of the moon. But we cannot take that to the level that we can actually fly it to the moon. So we have partnered with other companies, and we will be taking advantage of another of the NASA programs to land a payload on the surface of the moon by 2023 and conduct those experiments from work that we did in the laboratory. And then we team up with companies like Brett's that can take it up there and do all the things that we want to do, but we just don't have the capability of building the hardware that is required. And I think this is happening in several universities in the United States. And this is a great opportunity to conduct, to even have PhD students doing their thesis and getting results from the moon if they can wait enough years to get that going. But it's a great opportunity.
All right, the mic went dead on me. To you, Doctor, with new technological advancements and collaborative efforts, when do you think that a lunar presence would be sustainable?
Okay, that's sustainable is quite a word.
It's a big word, yes.
It's a big word. And actually, the associate administrator talked about how NASA is going through this sequence of just first finding the resources, doing some technology demonstrations. But he talked clearly that by the end of the 2020s, there's going to be at least a plan that will satisfy the needs of NASA for a sustained presence with a crew, let's say, of 4 or 5 people. So that is sustainable from NASA, but it's important to understand that sustainable for a company is quite different. And this is where we get into, what are resources and reserves for space agencies, for companies. So while NASA may have a setup in which they can produce oxygen so that it can satisfy the needs on the lunar surface for a crew of 4 or 5, for a company, they may need a larger unit to get propellant so that a launching company can actually refuel from space. So this is where that type of conversation needs to be had. And you're going to be hearing probably this afternoon or tomorrow from Clive Neal that is suggesting a lunar resources prospecting campaign that brings together universities and space agencies and companies to precisely do that, define what are resources and reserves for each one of the shareholders. I mean, who will be for what's good for NASA, what's good for companies, what's good for other countries, so that we can all benefit from this. So yes, the time frame is different for each one of the different users, but I think that by the end of the 2020s, NASA will have, or at least the plans are to have a sustainable operation for crews that are going to be on the surface of the moon.
We won't hold you to that. That's a great answer, though. I'd love to see that in the next 10 years. We're running low on time. I'm going to hit you guys with one more question. We're here at Bowie State University, and the three of you cover 3 different sectors: academia, industry, and the military. What skills would you like to see more of to help foster innovation? What would you like to see coming out into your various areas of innovation more, from colleges, from universities, from the students you teach?
I think this is an extremely exciting time in which it used to be that you will require aerospace engineers or software engineers to work in aerospace. Now you need everybody. You need from people that geologists and geophysicists and mining engineers and roboticists, economists, lawyers, everybody's needed for this new phase in space. So this is an exciting time in which you just have to identify, or each student has to identify where they fit in, and there will be a place for them. So I think the field is wide open to conduct this new phase of space of utilizing the resources and making all sorts of operations long term.
Brett, any thoughts?
Yeah, I mean, we're essentially a hardware company at our core. And so for us, we're always looking for people that have real interest in hands-on experience that has been coupled with the theoretical of what they've gotten at school. And we see that more and more. We see the people coming out of these universities, even without job experience. It used to be that you got the hands-on through your internships in the summers and whatever, but we're seeing much more with the schools, the curriculum within these schools, especially for the kinds of engineers that we bring on: mechanical engineers, electronics engineers, mechatronics engineers, robotics engineers, even computer engineering and software, where they are much more steeped in real world, practical applications of whatever the engineering theory is that they are studying in those particular disciplines. And that we find very, very valuable, because for a small company like ours, we're not a Northrop Grumman or a Lockheed. We don't have a huge training program, that kind of infrastructure. We basically need these students to come in after graduation and hit the ground running and make a contribution immediately. And the more that universities emphasize sort of the practical applications within their engineering programs, the larger the benefit is for especially the small business community like myself. But I would imagine it's helpful all around. They just come in much more prepared for hitting the ground running in terms of making meaningful contributions very, very early in their career.
Thank you. And Colonel, we'll give you the last minute and the last word.
Yeah, so on this question, I have to totally agree with Dr. Abbud-Madrid. Everybody. We're not talking about just delivering a specific system here. We're talking about building an entire industrial base, filled with a number of technologies that need to come together in order to make it all work. So that includes everyone. Engineers of all skills, scientists to offer, that deep thinking, and then, even business guys like me to really energize the effort by aligning the proper resources to properly invest in scale technology, right? So, this is a very exciting time to be working within the space industry. because of all of the opportunities out there. So, I encourage students from academia with just, with any interest in space to come in and partner with us. And it doesn't have to be, in joining like the Spaceworks. You can partner with us by joining a startup that's getting after space technology. You can partner with us by, producing the next generation of engineers through your academic institutions. So there's so many ways to plug into the space industry now. And so, so I would say everyone needs to get involved.
Great. Well, that concludes our time for this panel. Thank you, all three of you. It's been very enlightening, and I'm sure we all deeply appreciate your insights.
Thank you, AJ.
Thank you very much.
Very
Nice
much.
to participate.
Thank you so much. That was fantastic. And what I'm really excited about is I think we got the message earlier that internships are really key for getting opportunities for students. I think the other thing that this has brought to into my mind while I'm sitting here is that leveraging partnerships like with SAIC and Goddard and Bowie, where you can provide more schools opportunities to offer the hands-on experience, would be really helpful to help broaden the base of innovators across the country. So I think it kind of like ties it all back together really nicely. So thank you all so much for joining us. And I'm looking at your pictures on the giant screen, so you can't see my tiny little face on the screen here.